Long before we had AI that could write an email or create a picture, the real pioneers were asking a much more fundamental question. What would it actually take to build a machine that can think? Well, back in 1961, one of the godfathers of AI, Marvin Minsky, published a paper that tried to answer that exact question. And it wasn't just a paper, it was a blueprint, a roadmap for a journey that you could argue we're still on today. So let's dive in. Minsky kicks things off with this brilliant thought experiment. He says, imagine you're an alien visiting Earth in 1961. You'd hear people talking about these new mechanical brains capable of incredible things. But then you'd also hear them being called slavishly obedient and just inhumanly dull. So you've got this wild contradiction, right? And that's the whole paradox Minsky wanted to solve. Are these new machines just really, really fast calculators, or are they the very first spark of something more? All right, so here's how we're going to break down his thinking. First, we'll dig into that central paradox. Then we'll look at the actual roadmap he laid out for building an AI. We'll hit the big roadblocks he saw, like why just trying everything, brute force, is a total non-starter. And then we'll get to his elegant solution for making the search smart. Finally, we'll see how it all pulls together into a machine that can learn and plan, and you'll see just how much this old blueprint still shapes AI today. Okay, first up, the computer's paradox. Let's really dig into this core question. You have to remember, Minsky was looking at a world that was just starting to grapple with what these new computer things could even do and what they couldn't. But here's the thing. From Minsky, this wasn't a problem, it was an opportunity. He basically said, look, we're standing on the threshold of an era of intelligent machines. That gap between dull and brilliant wasn't a flaw in the computers, it was the wide open space where a brand new science could be built. And you know what he called that science? Artificial intelligence. So that's the big question, right? How in the world do you get from a machine that just follows orders to one that can actually have an idea? Minsky knew you couldn't just flip a switch. His real genius here was realizing that you had to take this enormous, impossible-sounding goal and break it down into smaller, manageable chunks. And these are the chunks he came up with. It all kicks off with search, how a machine can even look for an answer in the first place. But just searching blindly is useless, so you immediately need pattern recognition to help it spot what's important. Once it can see patterns, it can start learning from them. And once it can learn, it can start to plan ahead. And the holy grail of it all? Induction. The ability to make up new rules based on what it's seen. This wasn't just a list for Minsky. It was a ladder, step by step for building a mind. All right, let's climb that ladder, starting right at the bottom with the most basic problem of them all, search. The idea seems pretty straightforward. If you can tell a computer what a correct answer looks like, why not just tell it to try every single possibility until it finds one? That's called a brute force search. Yeah, there's just one tiny issue with that approach. As Minsky points out, for any problem that's actually interesting enough to solve, this is a completely terrible idea. The number of possibilities doesn't just get big, it explodes exponentially. It's not just slow, it's fundamentally impossible. I mean, just look at this number. That's for the game of chess. It's a 1 with 120 zeros after it. To put that in perspective, Minsky wrote that you could take every single particle in our galaxy, turn them all into a giant computer, and it still wouldn't have enough time to finish the calculation. So yeah, brute force is not the answer. We've got to be smarter. So what's a smarter way? Well, one of the first clever ideas Minsky discusses is called hill climbing. The analogy is just perfect. Imagine you're on the side of a huge hill, but it's completely foggy. You have no idea where the peak is. What do? Well, you just feel the ground under your feet and take one step in whichever direction goes up the most, right? And you just keep doing that. That's hill climbing in a nutshell. And this is so cool. We're actually looking at Minsky's own hand-drawn diagram for how this would work. Think of each of those boxes as a little dial the system can tweak. It just kind of jitters each one, makes a tiny random change, and then checks the main meter to see if things got better. If they did, it turns the dial a little more in that direction. It's literally feeling its way to the top. So simple, but so brilliant. But, and there's always a but, isn't there? This method has a fatal flaw. What if you're not on one big mountain, but you're in a whole range of smaller hills? Your little hill climber will happily scramble to the top of the first foothill it finds, plant a flag, and stop. It has absolutely no idea that Mount Everest is just across the valley. It gets trapped on what Minsky called a local peak. And for really hard problems, this happens all the time. So that brings us to the next crucial step on Minsky's ladder. If wandering around blindly gets you stuck, you need to give the machine a better way to see the terrain. You need to teach it how to recognize important patterns and features. You have to make the search smart. And Minsky draws a really key distinction here. One way to recognize things is with a rigid template, kind of like a stencil. To find the letter A, you look for something that perfectly fits your A stencil. But that's super brittle. If the A is tilted or squished, the stencil doesn't fit and it fails. The much more powerful way is to use a property list. Instead of a stencil, you ask questions. Does it have two lines that meet at a point? Does it have a bar across the middle? It's about recognizing the idea of an A, not just a perfect picture of one. And this illustrates the point perfectly. Take a look at these pairs of shapes. A simple template matcher would say they're totally different, no question. But you and I can see they're basically the same thing, just stretched differently, right? They share the same fundamental structure. That's the goal, to get the machine to see past the surface and understand that a perfect cube and a long stretched-out box are, in a deeper way, the same kind of object. So how did Minsky propose we actually do this? With something he called a character. It's basically a unique fingerprint for a shape. You just make a checklist of properties. Is it made of straight lines? Yes, that's a 1. Is it all one connected piece? Yes, another 1. Does it have a loop in it? Yes, a 1. All of a sudden, a complex visual object like a square gets boiled down to a simple signature, 1, 1, 1. Okay, so you've got all these properties. How does the machine combine them to make a final decision? Minsky described this awesome model that inspired a famous AI system called Pandemonium. Picture it like this. At the bottom, you have a bunch of little data demons. Each one is only looking for one specific thing, like a vertical line or a sharp corner. When they see their thing, they start shouting. Then, a layer above them, you have cognitive demons, and each of them is listening for a specific combination of shouts. The one that hears the evidence it's looking for shouts the loudest to the big boss at the top, the decision demon, who makes the final call. It's organized chaos, and it works. So at this point, our machine can search more intelligently because it can recognize patterns. The next level up is to combine these pieces. We need a machine that can actually learn from its experience, and this is the big one, plan ahead. But this introduces one of the hardest, most persistent challenges in all of AI, something Minsky's work really throws into sharp relief, the credit assignment problem. Think about it. If you win a chess game after 100 moves, which move was the one that won you the game? Was it the final checkmate, or was it that subtle, weird-looking pawn move you made 50 turns ago that set the whole thing up? Figuring out which of your thousands of little decisions actually mattered, that is an incredibly hard problem. Minsky's solution was just brilliant. He basically said, don't try to solve the super messy, detailed problem right away. First, create a simpler, more abstract model of the world, like a blurry map instead of a high-res satellite photo. Solve the problem on that easy map first to get a rough plan. Head north, then turn west. Then, and only then, do you use that basic plan to navigate the messy, complicated real world. You're not searching blindly anymore. You have a strategy. And that brings us to the legacy of this incredible paper. When you really step back and look at the structure Minsky laid out all the way back in 1961, it is just astonishing how much of it still defines the entire field of artificial intelligence today. I mean, really think about it. Search, pattern recognition, learning from data, planning and reasoning, these aren't just historical footnotes. They are the absolute fundamental pillars that modern AI, from game-playing engines to the large language models we're all using, is built on. Minsky didn't just predict the future. He literally drew up the architectural plans for it. And maybe this final quote captures his most profound insight of all. Minsky understood that real intelligence isn't just one magic trick. It's hierarchical. It's the ability to use simple results to build more complex ideas, and then use those ideas to build even more complex ones, layer by layer. It's an idea that is more relevant right now than ever before. Which leaves us with a final thought to chew on. Minsky gave us a blueprint for the very first steps toward AI. Now, more than 6 decades later, as we see AI achieving things he could have only dreamed of, it's worth asking ourselves, have we moved on to a completely new design? Or are we still fundamentally just taking the next steps on the exact path he laid out for us all those years ago?